Good morning, everyone. This is Chapter 7, Lecture 1 on memory. So, your book does a good job of outlining this chapter. It discusses the three basic principles of memory and does a good job of following those three basic principles throughout the chapter. Number one is encoding. Encoding means that when information comes into our memory to try to get into a longer term memory, it begins by changing that information into a form that your brain can actually utilize. Hang on a second. We gotta get this set up a little better. So it changes the form of the information, and that is the process of encoding. It's just like it's symbolically similar to what your device does. When you put information in your device to be saved up, it changes that information into a series of zeros and ones. So I have no idea what the letter A is in the series of zeros and ones, but maybe it's 010011 or something like that. I have no idea. But the letter A has a representation in a series of zeros and ones. That way your device, your computer, your laptop, your iPad, whatever it is, can understand what has been typed into it. Our brain does something familiar to that. It's not exactly the same, but it's somewhat similar. We don't know exactly what our brain does. We have some idea of how it goes about doing it, but we don't know how it does that. People with certain learning disabilities, such as dyslexia or dyscalculia, the information is taken in visually, and somehow in the process of taking that image and storing it away, it is changed. Either the letters switch places or the numbers switch places with extreme dyslexia or dyscalculia. And it makes it impossible, therefore, for that information to be pulled back out of memory in a correct fashion. And so a lot of good hard work has to happen to make that end up functioning better. The second basic principle of memory is storage. It has to be put away. We believe that storage process is biological, that there's actual physical tissue associated with that biological process. And that when we store away a memory, there is actual physical tissue in which that memory is contained. We'll talk about that a little later in the lectures. There's lots of different things that we know about storage, how the normal human brain goes about storing information away, and we'll talk about that. And third is retrieval. Ultimately, the information has to be pulled back out of memory and brought back to a normal state. Well, that's not horribly easy to do for some people. My first real experience with any kind of problem like that was my first exam that I ever took in graduate school. For some reason, I had somehow placed a whole lot of importance on this first exam. It was a class on intelligence testing. And it just happened to be the first class that came up with a test. And I remember going into that class and for the test and sitting down thinking I was prepared. And I looked at the information on that test, the 4 or 5 questions that made up the 2-hour test. And I was just distressed. Because, to be very honest, what I ended up coming to was that I remembered nothing. I had nothing in my mind. And I started to panic and I started to worry. And then all of a sudden I realized that this is something I had treated people for. Test anxiety. And lo and behold, I knew how to fix it. So I put my head back, I did a relaxation induction, did my heavy breathing, and went to the beach and breathed along with the waves coming in and coming out and all that. And it took about 10 minutes. But by the time I had myself relaxed, all of a sudden little ideas started binging up into my head because I worried that maybe I studied all the wrong stuff. And then I went crazy on the test because I was a good 25 minutes, half hour behind everybody else starting the test. And I wrote furiously, and I ended up getting a B+ on that test. And it still ticks me off a little bit because if I'd had the whole 2 hours, I'd have gotten an A on that dang thing. But that's what happens sometimes. So there are many potential problems with retrieval, and we have to figure out what those problems are. Okay. Well, we're going to start out by talking about 2 basic theories of memory. There are 2 major theories of memory. One's older than the other. Your book presents the newer one first. I'm more focused on the older one coming first because I think doing it chronologically works a little bit better. So, in your book for this chapter, you'll want to open up to page, let's see, oh goodness. Here we are. Page 7. Page 228 of chapter 7. And here's the display that I want you to be looking at in your book right here. This one right down here. That is the storage and transfer model of memory. Okay? The storage and transfer model of memory is the oldest model that we have of memory. Very good one. Still has a lot of very appropriate concepts. And it's not the whole picture. That's why we have a second model of memory that we're going to talk about. So, in the storage and transfer model of memory, the whole concept of how memory works is based on the amount of time that the information is in memory. There are 3 basic steps. There's sensory memory, there's short-term memory, and there's long-term memory. Sensory memory, very short amount of time the information is in memory. The short-term memory, not very long. We count it in seconds. And then finally long-term memory, which we count in hours. So let's talk about the difference. Sensory memory literally is about a 5-second memory at its longest. This is where information is just barely in memory. Researchers took a display of 9 dots put into 3 different rows and then flashed that 9 dots in 3 different rows up on a screen. The only problem was one of the dots was missing. Now when they flashed it up on the screen, they flashed it up for 50 milliseconds. A millisecond is 1/1000th of a second. So 50 milliseconds is 5/100ths of a second, or a 20th of a second. So a second, 1/1000, you take 20th of that. That's how fast that was flashed up onto the screen. And then the subjects had a piece of paper in front of them with 9 dots in 3 rows out in front of them. They would watch the screen, it would flash, and then they were told to respond by pointing to the dot that was missing. Now, when they were asked to point at the dot that was missing in 2.5 seconds or less after it was flashed, they most of the time always got it right. If they were asked 5 seconds or more after it was flashed, they most always got it wrong. So that says that that physical image was in their mind for a brief few seconds, but then it was gone. That's sensory memory. Okay? We have both visual and auditory sensory memory. Now, short-term memory is a little different. Short-term memory can last anywhere from, some people say it can go down to 10 seconds and then it's gone, but for most people it's more like 15 to 25 seconds. And so the average amount of time that short-term memory is in your brain is about 20 seconds. So this is when somebody gives you a phone number and they say what the phone number is, and you quickly, well, not quickly, if you wait more than 20 seconds, it's probably going to be gone before you try to write it down or something along those lines. Although you do have the ability to some people keep it around for longer, but if it's short-term memory, it's only going to last about 20 seconds. That is immediate short-term memory. There is also rehearsed short-term memory. Rehearsed short-term memory is what some people do when they take a test. They will cram for the test, and they'll do it for about a half hour, 45 minutes, and then they'll get into the test, and they do pretty well. But that's rehearsed short-term memory because you're reviewing it over and over. And then once you have it in there, it's there for a brief amount of time. But if 4 hours later you were asked to take the test again, a lot of it may not be there any longer. But that would be rehearsed short-term memory. And then finally, there's long-term memory. Now, long-term memory, it has to be in memory anywhere from 4 to 6 hours. And it is permanently stored away, if that's the case. Now, most of our memory storage that we do is done during sleep. So a lot of that occurs during REM sleep, where we store away the day's memories. That's also one of the reasons why when we dream, we have a difficult time with that whole process of dreaming, because to be honest, new information will bump up against old information that it's trying to store away. And so sometimes we have old images and brand new images from that day coming together in the same dream. And that's often the explanation of why that occurs. Now, there is another concept in the storage and transfer model of memory. Now, the researchers in the storage and transfer model of memory are Atkinson and Shiffrin, and you need to know those names. Atkinson and Shiffrin did a lot of good hard work with this. This other concept in the storage and transfer model of memory is not another stage of memory. There are only 3: sensory, short-term, long-term. But this other concept is an important concept. It's called working memory. And working memory is something that, for example, individuals who have memory problems may struggle with. Working memory is like I'm sure that all of you have written quite a bit of your paper at this point. Well, I hope you have, because I think I put it out on one of your messages that your announcements that I sent out to you, that your project will be due on June 12th, Friday, June 12th. So remember that. At least this is for spring quarter. Let's say that you have 3.5 of the 6 pages that you're planning on writing completed. Well, when you go to work on that, you're going to pull it up out of your hard drive, and it's going to be on your screen. And then you're going to work on it for a while. You're going to change a few things. You're going to take a paragraph that's down here, and you're going to move it up here, and then you're going to add some to this paragraph and write a new paragraph, and then you're going to save it away. That's working memory. When you bring up information that's in your hard drive, in your long-term memory, and you bring it up and you work on it in your head, and you add some things to it, and you revise some things in it, and then you put it back into your long-term memory, that's working memory. And interestingly, we do a better job of remembering the new information that we've added with working memory, because now we've associated it with information that's already in long-term memory, and we find that that always helps with memory. Associations are a very helpful thing with long-term memory. Okay, so let's see. Well, that's what I want you to do with I want you to know with the storage and transfer model of memory. Now, the second model of memory in your book is on page, oh, wait a minute, it was before storage and transfer model. This is the levels of processing theory. The levels of processing theory is on page 225. Now, the levels of processing theory is more focused on the depth that the information has been understood, as opposed to the length of time that it's been in memory. So think about it for a moment. If you were alive on 9/11 and you saw the plane slam into the towers, you didn't have to see that more than once for it to be permanently engraved in your mind. And there are many iconic memories like that that are just burned into your memory immediately. It didn't have to be in there for a long amount of time. In fact, it didn't have to be in there for much time at all. So we can have information that is deeply engraved in our memory, but didn't have to be there for 4 to 6 hours before it was deeply engraved in our memory. So there are aspects of memory that are not fully explained by the storage and transfer model of memory with Atkinson and Shiffrin. Instead, there are some aspects of memory that are better explained by the levels of processing theory. And this is Craik, Lockhart, and Tulving. You need to know those 3 researchers who worked on this, this whole memory process quite well. So, like I said, this is on page 225 in your book, and want you to follow along with me as we talk about the deepening levels of processing. Okay, so there are deepening levels of processing. What does that mean? Well, that means, first of all, the levels are shallow, intermediate, and deep. So there are 3 levels. Shallow, of course, is the least amount of processing that goes on. Intermediate processing more, and then deep processing, those deeply engraved memories that stay with you for an extended period of time. Okay, each of these levels of processing has a different type of encoding. Now, this is the encoding, which is number 1 in the 3 basic processes of memory that this chapter is based on. So encoding, storage, and retrieval. So this is encoding, getting information into a form that it can put it into your memory and have it stay there. So, shallow processing uses structural encoding. Now, I want you to think of the word dog, okay? It can be written in block letters, but lowercase block letters. It can also be written in uppercase, capital letters. It can also be written in cursive. Now, I want you to see in your mind those three different ways of writing dog. Do you have to know what a dog is to be able to determine that the structure of the spelling of those three different ways is different? Well, yes, you can distinguish between them. This is like driving down the freeway and you glance up for a moment at a sign on the freeway and you haven't read the words at all, but you can tell whether or not it's in block letters or whether or not it's written in beautiful script. Okay? That's the structure. That's structural encoding. That's all that you recognize is just the structure of the concept. Okay? That is structural encoding. So dog, small letters, dog capital letters, dog cursive letters. Okay? Now, intermediate processing. This is the second level of this theory. This is phonemic encoding. Now, the word phonemic sounds like phonetic, and that's exactly what it means. So, is it easy to remember something if we put it in a rhyme? Yeah. When things rhyme, then we've associated them. Well, what rhymes with dog? Dog, log, hog, bog, smog. Okay? It's easy to remember these words when they rhyme. Well, that is phonemic. So that's a deeper level of processing than structural. You still don't have to know what a dog is, though, to be able to remember that there's log, hog, bog, and smog that rhyme with them. Okay? Then finally, the deepest level of processing, deep processing, uses semantic encoding. Now, what does the word semantic mean? Now, that's a little bit of a pun, isn't it? Because semantic means meaning. It has to have the meaning. You have to understand what it is. So what's a dog? A dog's a mammal. A dog is of the canine family. It has fur, and it has 4 legs, and it has a tail, and they're man's best friend, and all that kind of stuff. Okay? And I like dogs. I don't like cats much. I like dogs. Sorry if you like cats. But honestly, what's a cat's job? Cat's job is to figure out a new way to ignore you. It's not what a dog does. Dog is your friend whenever you want it to be your friend. I actually have 2 books. One's called the Official I Hate Cats book, and the other one's called 101 Things to Do with a Dead Cat. They're great books. I don't hate cats. We just owned 2 of them years ago, and they both pissed on my house, and I didn't like that. So, and cat pee, oh my gosh, it's the worst thing in the world to get out. So I like dogs. All right. But semantic encoding, a deeply understood concept of exactly what it is. That is semantic encoding. Okay? So, those are your 2 theories of memory. Okay? Now, let's talk just a little bit, if you go along in your book, let's talk about attention in the process of encoding. To encode something, don't you need to pay attention to it? If you don't, you're not going to encode it. You ever heard of the term dichotic listening? This is a research method where 2 different messages are sent to each ear. Like one is a sports event, and the other is somebody reading an assembly manual of, some piece of furniture. Well, you can tell which one's going to be more interesting, and you better say a sports event. But what is it that maintains your attention? Well, one thing would be interest. Hopefully you're more interested in the sporting event than you are in an assembly manual. But what else could be something that magnifies the attention of one versus the other? Well, one thing they would do is slowly increase the very boring topic in volume. More and more and more, and people are able to factor out a very loud thing to listen to something they're very interested in. But once it gets to a certain volume, it overwhelms the interest on the other one, and all you can listen to is the louder one. So volume would be a factor that determines attention. And there are many other factors like that that can retain your attention more than others. The size of an image you're looking at, as one gets larger and the other gets smaller, well, there's going to be a point where you stop focusing on the smaller one and you focus on the bigger one. So again, these are things that attend to that process. Okay, well, that's all we're going to talk about with encoding. Now we're going to talk about storage. What do we mean by storage? Well, how much do we put away and how long does it stay there? Well, let me look down here real quick and see how far. Okay, I know how much we have to cover. All right, so let me talk about just a couple of terms. Okay, how about flashbulb memory? Flashbulb memory is one of those things that I mentioned to you, one of those iconic images that a whole society is familiar with and understands and knows. That flashbulb memory is the space shuttle blowing up in mid-flight. That was one that people don't ever forget. How about back in Ronald Reagan's time when the Iron Curtain fell, and there was that image of that guy standing on top of the Berlin Wall and slamming it with an ice pick and a chunk of it falling down. Those are kind of iconic images that we see over time. The young girl running away from a horrible attack, and she's scarred all over her body, and she in the Vietnam War. An iconic image, horrible image. That woman actually lives in the United States now and suffered from those horrible burns. Those are the kinds of things that we see that are so iconic, so very much there. That's flashbulb memory, so iconic, major memory of those significant issues. Let's talk about the serial position effect or the serial position curve. Okay? The serial position curve. Let me try to draw it here. I'll find a piece of paper I can use. Okay? So, when we say serial position curve, when we talk about serial, we're not talking about Captain Crunch. We're talking about the series that something is presented to you in. So you're presented 15 words in a series. What are you most likely to remember? Well, here's the number of words on one side of the graph, and down here there's the first 5 words, the second 5 words, and the third 5 words presented to you. So here's the number of words remembered on this axis, and on this axis here you have first 5, second 5, third 5. Okay? This is actually the setup for a memory test that we give called the Ray Auditory Verbal Learning Test. So when I do a psychological evaluation and I find that someone is showing some issues with memory, I will give them some of these very brief, quick and dirty neuropsychological tests. Now, I'm not a neuropsychologist and don't pretend to be, but I can get some good information that can then potentially refer someone on to a neuropsychologist where they may need to do some more extensive work. But here's what the serial position curve looks like. People have a tendency to remember the first 5 words and the last 5 words at a much higher level than they remember the middle 5 words. This is called the serial position effect. The tendency to remember the first 5 words is referred to as primacy. Okay? Primacy, or the primary words, first words. And the tendency to remember the last 5 words better than the middle words is referred to as, or any of the words, is referred to as recency, or how recently the information has been presented to you. So there's primacy, tendency to remember the first words in a series, and recency, the tendency to remember the last or most recently presented to you information in a series, whereas the middle is left out. I've done this probably for 20 years. I did this in classes where I would have the students, I would read them a list of 15 words. And then, after I did that list of 15 words, I would ask them how many of the first 5, second 5, and third 5 did they remember. And as a class, it was always about 3 of the top 2 and about 1.5 of the middle. So primacy and recency does show up very regularly in these kinds of serial memory. So these are just some of the examples of how these pieces of information are often presented to us. But let's take a look at some other concepts, some better concepts that maybe are easier to help you remember it all. So there are 5 terms I need you to know. And that's going to wrap up, after we're done talking about these 5 terms, we're going to wrap up today's lecture. The first is called chunking. The term chunking is how our tendency to remember unrelated items in a group. Now, what do we mean by unrelated items? Well, if you're working with words, there's always going to be potential associations that you can make between words. Therefore, words aren't going to very easily be unrelated. But you can choose certain things that are unrelated. How about just symbols? Or how about numbers? And when I say numbers are unrelated to each other, I would mean that just because the number 3 is in the same group as the number 8, it doesn't mean that you're going to remember either one better just because the other number was there. So they're not really related to each other when it comes to memory. That being the case, we chunk information together when we do chunking with unrelated items. So when somebody gives us a phone number, how do we remember them? What kind of chunks do we put them in? Well, we put them in chunks of 3, 3, and 4. Our chunking abilities tend to be chunks of 2, 3, or 4. Think of all the important numbers you have to remember. Think of your student ID number. Think of your Canvas ID number. Think of your Social Security number. How do you always remember them? In chunks of 2, 3, or 4. Okay? It's natural for us to remember things like that. And it doesn't matter what the symbols are, and it doesn't matter how complex or very primitive a culture is. People remember information in chunks of 2, 3, or 4 if the items are unrelated. Now, if the items are related to each other, our tendency to remember them we refer to as clustering. So we remember information in clusters of content. So, in the Ray Auditory Verbal Learning Test, there are 15 words. It's a very simple test. The 15 words are read to the subject. The subject repeats as many as they can remember. Then it's read a second time, and a third time, and a fourth time, and a fifth time. And then it's interfered with a little bit. And then it's read, or not read again, but they have to try to remember it a 6th time. Well, each one of these recitations makes it easier for the person to remember. Well, in that series of words, there are 6 words that if somebody grew up on a farm, it would be easy for them to associate those words with each other. So there's garden, farmer, hat, turkey, house, and river. Well, that's 7. How many of you would remember those easily if you grew up on a farm? Well, yeah, maybe you grew up on a farm and there was a river nearby and there's a house on the farm and there's a garden and there's a farmer and you've got a hat on and there's a turkey running around in the farm. Okay, those things would be easy to remember together because they all have the same association to the farm. That's what we mean by clustering. Information is clustered together in content areas. And so they are associated items. That's clustering. Now, the next term I need you to know is something called a conceptual hierarchy. Now I need a new piece of paper to be able to do this. So, got to get a couple pieces of paper over here, and I will draw a few things that will help you remember what these terms are. So, conceptual hierarchy. The definition of a conceptual hierarchy is a multi-level classification system based on common properties among items. All right, that's just going to confuse you. This is on page 233 in your book. A multi-level classification system based on common properties among items. Multi-level. Well, if you're taking notes on these lectures, or if you even just look at the study guide I've given you, how is it very roughly set up? Well, when you take notes, you generally set things up in the form of an outline. Is an outline a multi-level classification system based on common properties among items? Well, yes, it is. You have the big headings, then you have lesser headings underneath, and so it's multi-level, and the organization of those informations into the multi-levels are based on common properties among those items. There's another way of looking at it. So let's say we have cars, trucks, and motorcycles. Okay? So we have 3 chunks here. Cars, trucks, motorcycles. Now, are there different makes of cars, trucks, and motorcycles? Well, by golly, there are. So, cars, let's put Toyota. Let's put Chevy. And let's put BMW. And under trucks, let's put Honda. Let's put Dodge. And let's put Mercedes-Benz. Did you know that Mercedes makes a truck? They actually do. And under motorcycles, let's put Kawasaki. Let's put I'll have to think about that for a second. Let's put, got to put Harley, right? And what's that Northern European motorcycle company? It's a long name. Dang it, I can't remember it. Husqvarna. Okay? Now, this is a conceptual hierarchy. Here's cars, here's trucks, here's motorcycles. And there are common properties among items that you've divided them into. Cars of different makes, trucks of different makes, and motorcycles of different makes. Okay? I'm going to do something more with this in a minute. what I'm going to do now is I'm going to turn this conceptual hierarchy into into a what do you call it? Oh, come on. Gosh, dang it. Into a semantic network. That's right. Okay. So let's try to figure out what a semantic network is. Well, let's get the definition of a semantic network. A semantic network consists of nodes representing concepts joined together by pathways that link related concepts. Okay? Well, let's see what this means. Are cars, trucks, and motorcycles nodes? They are. They're nodes. They're pieces of information, and that's what a node means. Okay? And I would call a semantic network a conceptual hierarchy on roids. Okay? So let's see what that looks like. Well, I'm going to, goodness, where did I put my pen? I'm going to put these in a different format. Chevy over here to Harley, Harley to Dodge, and Dodge over to Chevy. Okay, first line I've made here is just the pen line. And what have I connected? I've connected Chevy to Harley, Harley to Dodge, and Dodge back up to Chevy. Now, with the big black marker, I'm going to connect Toyota to Kawasaki, Kawasaki to Honda, and Honda to Toyota. So, Kawasaki, Toyota, Honda, right? And now I'm going to connect BMW to Mercedes-Benz, Mercedes-Benz to Husqvarna, and Husqvarna to BMW. That's the blue one right here. How have I reorganized this information? So I've got nodes. The nodes are both are motorcycles, cars, and trucks. Well, these makes are nodes also. And how have I reorganized them? Well, I've connected all of the Japanese, Honda to Toyota to Kawasaki. I've connected all of the European brands, Mercedes-Benz, BMW, and Husqvarna to each other. And I've connected all the American brands, Chevy to Harley to Dodge. So it's just a different way of organizing the information, but that means they are nodes. All these little things are nodes representing concepts joined together by pathways that link related concepts. So again, this is the use of relationships between the items in a different way. So a semantic network is a structural hierarchy that you've then expanded with the number of associations you can make. These things make it easier for us to store information away when we create all these associations. Okay? Now, the last concept I'm going to want you to be familiar with in today's lecture is a schema. Let's define schema. A schema is an organized cluster of knowledge about a particular object or event, abstracted from previous experience with the object or event. Now, this is on page 233. I want you to have your book open, and I'm going to ask you to do something. I don't want you to look at your book before I do this. I'm going to ask you to look at that black and white picture that it's in the bottom right corner of page 233 in a moment. Don't look at it yet. But I want you to stare at it for 5 seconds, and I'm going to count to 5. And when I'm done, I'm going to ask you some questions, but I don't want you to look back at the picture, okay? I want you to do it honestly in your head. So ready? I'm going to say ready, set, go. And when I say go, you're going to stare at the black and white picture for 5 seconds. Ready, set, go. 1, 2, 3, 4, 5. Now, don't look at it again, and I want you to answer in your head, how many desks are in that picture? Now, some of you are going to say 2, some of you are going to say 3, but I want to point out to you that there are no desks in that picture. Every one of those is a table, not a desk. Now, I tricked you, but what does that mean? Well, in an office, what do you expect to have in an office? Desks, okay? And I said, how many desks are in there? And of course, that's your already existing premise. Now let's read the definition again. A schema is an organized cluster of knowledge. An organized cluster of knowledge would mean like an office about a particular object or event. So this is an object in this case, an office, and your organized cluster of knowledge about that office, abstracted from previous experience with the object or event. That means you've had previous experience with offices. Therefore, when you look at a picture of an office, you have a presupposition of what is going to be in that office. And that usually includes, lo and behold, desks. Well, there are no desks in that office. There's only tables. I could have asked you, how many books are on the shelves? And you might have given me a number, but then if you look closely, there ain't no books on the shelf. But what do you expect to be on shelves in an office? If I'd asked you that question, you probably would have come up with a number. Okay? All right. That's what a schema is. You've had previous experience with something, and you bring that information in with your observation. And sometimes it makes your observation a little off base. Sometimes it helps it. This is why eyewitness testimony isn't the greatest thing in the world. A defense, if there is going to be eyewitness testimony in a criminal case, a defense attorney wants there to be 28 eyewitnesses, not just 1 or 2. If you are a prosecuting attorney, you want only 1 or 2. Why is that? Because everybody sees things a little bit wrong. And so if it's 28 people, you can find little differences between all of them and then make that look like nobody has actually seen the same image the same. If you only have 1 or 2, there might be a little difference between them and no big deal, right? Well, that's because memory is not as perfect as we like to believe it is. Certainly eyewitness testimony is not. From the research of, what's her name? She's in the book here somewhere. I can't remember her name. Elizabeth Loftus, that's right. I've listened to her at a couple conferences in times past. So, that's today's lecture. We've talked about storage and encoding. The next lecture, we're going to talk about retrieval, and then a number of other items associated with different aspects of storage and retrieval. So, good to talk to you, and I'll hope to have the next video up for Chapter 7 quickly. Thanks a lot. Bye-bye now.